Assalamualaikum and good morning to everyone. Today I am Muhammad Ulul Sarif. I would like to present to you about introduction to our team project focus on design and simulation of a 6-degree freedom robotic arm for car body spray painting. So in the era of Industry 4.0, the automotive sector is moving rapidly towards smart automation. Traditional car painting relies heavily on manual labor, which leads to issues such as inconsistent paintiness, material waste, and health risk due to the abuse of PLC. This manual process also struggles to meet the speed and precision demand of the modern car production. To address this problem, robotic arm, especially those with 6 degrees of freedom, offer precise repeatable motion across the complex surface. They can follow 3D paths, maintain optional spray angle, and reduce overspray using a real-time feedback and machining algorithm. So the objective of this project, first, is to select and justify a suitable robot configuration. Second, develop a 2D or 3D CAD model of the robotic arm. And the third is derive a forward kinematic using the derivative Haziq method to control the spray nozzle position. I think that's it from me. I will pass to the net person. Thank you.
Hello, my name is Shafwan. Today I will present the design and simulation of robotic arm created for automatic car body painting. So our goal is for precision reach and adaptability to paint a 4.5 meters times 1.8 meter times 1.5 meter cars. So this design is designed and illustrated by using the software SolidWorks. So let's go to our design here. You can see already our design. So our design is the center robot work cell, so which has the 6 degree of freedom. So for better visualization, I can see you here the diagram of the 6 degree of freedom. So we have the revolute, all of the robotic joint is revolute, not in prismatic. So we have the 1 revolute here, 2, 3, 4, 5, and 6. Alright. So it has 5 joints allowing flexible movement to cover all car surfaces. Also rotational joint for base, shoulder, elbow, wrist pitch, and also wrist rolls. So each joint is powered by electric servo motor for high precision, and for the sensor users is the proximity and position sensor are integrated for path accuracy and collision detection. So this is how we're going to simulate our robotic arm. So we have the degree of freedom here. It can rotate for the car to paint, and it can move up and down. Also it has reach here, and this one also can be reached, can be moved. So this is how the robotic arm is done to spray our car. So we can see that it has a smooth joint coordination and its ability to reach all car surface because of the size and also all the joint that is integrated at the robotic arm. And we can see that it's no collision during movement. So it has a smooth and we can see no and very little collision during movement. So the simulation also ensures proper path planning for smooth and even paint application. So in conclusion, this robotic arm was successfully designed and simulated to meet the painting task requirement with high precision and adaptability. Thank you very much. So for the DH, I forgot to mention. So the movement is also using the Danial method, which is DH method, will be presented by our next friends for the next presentations. So that's all from me.
My name is Ahmad bin Muhammad Zuramee. My metric number is 23106-1717. I will present to you my part of the assignment, which is the calculation part. So basically for the calculation part of our 6-joint articulated robotic arm, so I've drawn the diagram onto paper and I want to calculate the DH parameter. So basically what we have here is the joint number 1, which is theta 1, which is the base joint. And then we have theta 2, which is the second joint, theta 3, the third joint, theta 4, 5, and 6 respectively. So basically, after labeling all the critical components in the calculation, in the diagram, I made the table. And since this is using all revolute joints, there's no prismatic joints. As you can see, the diameters or the distance of joint 1 and 4 is around 7 and 11 meters. And for joint 2 and 3, the A distance is 2.5 meter and 9 meter. So for the alpha, for joint 1 is 90 degrees, and for joint 3 is 90 degrees also. But joint 2 and 6 is 0. 3 and 5 is 90 degrees. Next, this is how I calculate the final transformation matrix using the formula. So I plug in the formula from the table into the formula, and this is what we get. So for A1, we get this one, and for A2, we get this one. A3, we also get this one. A4, the formula, and then plug it in and then calculate and get this one. Same with A5, A6, and so total there's only 6 joints altogether, right? So the final transformation matrix we get is A1, A2, A3, A4, A5, and A6. So this is the calculation for our painting robot, which involves using the design we selected, which is the articulated robotic arm. Thank you very much. This is all from my part.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Wafiq Haziq with Muhammad Nazri. And for conclusion, we have implemented a 6 degree of freedom or 6DOF robotic arm within a dedicated robot center work cell, which will maximize our efficiency to spray paint the automotive. The flexibility and the precision offered by the 6DOF allow the robot to reach every surface with optimal angle, which is something that manual labor or with the simpler robotic machine with smaller DOF will be hard to achieve. By centering the operation around the robotic arm, hence the robot centered workspace or work cell, we create an environment tailored for maximum efficiency, making the workflow streamlined, hence making the paint quality become constantly high quality across all vehicles. And also, since we are using robot to paint our car, the worker exposure to more hazardous material are drastically reduced. Hence, this is not just to automate painting, but also can be marked as a new standard for safety, productivity, and product uniformity in modern manufacturing. Thank you.